with them. We had to scrap, well, not scrap, but we had to replace one of the castings. It was just previously improperly machined. So we've got all our guides and all our seats situation corrected. We did the valve job on it and all that. Rather than me filming the thing, me doing the valve job, basically all you're going to see is my back as I'm down there working on it. I'm not set up properly for getting proper camera angles and all that kind of stuff. I'm working on it. I'm learning it all. So what I decided to do is I'm just going to show you, come in with some close-ups, explain a few things. We're going to go to a whiteboard and I'm going to explain some of the porting theory, some of the valve seat requirements and all that kind of stuff. I hope you guys get something from it. I hope it's educational, and, well, let's get going on it. So here's our heads. This was the original head. This is the one I replaced with one of my castings, same number. So if you look closely here, you can see our different valve seat angles. You can see the numbers on the head here. So our top cut is that one there. It's a 10 degree and it's 30 thousandths wide. You'll see I have the same numbers on all of these. For me, when I'm redoing a cylinder head, consistency is the utmost important. I want every valve seat, every valve, every throat diameter the same. Okay, so there's our 10 degree cut. We used our 10 degree cut to help dress the top, and we'll get into that a bit more later. Right here is my 30 degree cut. It is 60 thou wide on all of them. Actually, I think I ended up with one that's about 70 thou, but that's incredibly, insanely close. Our 45 is this one right here, okay? And on my intake, my 45 is 60 thou thick. And when we go to the board, we'll explain some of the thicknesses. Down here is my 65 thou, or my 65 degree cut. We bring that in to narrow our seat width to the specified number we want, which was 60 on this case here. And then underneath that is the throat. The throat, we ported with our die grinder and all of that and our hard rolls to a very specific diameter. We'll get into that on our whiteboard. And basically what I do there is I cut down a valve so it fits within there. I also use cut down valves on the exhaust also. Okay. The other thing we did was the flat space here in between our top 10 degree cut on the intake and the exhaust. We had a fairly substantial lip from previous rebuilds. We take valve, we set it in to protect the seat, and we dressed all of this down with a hard roll. And we'll show you exactly how far we took it down when we go to the whiteboard. So, the guides have all been corrected to spec. The seats have all been ground to very specific numbers, as you see on our heads, to a proper depth. And I'm going to take you to the whiteboard now, and I'm going to explain some of the theory and exactly what we did. I think that's better than, you know, you looking at my back while I'm trying to grind seats. Let's start out with how often your valve jobs are done, and we'll show you some of the problems with that. Here's your port, comes down, and then we'll call this the intake, and then here's your exhaust. Okay, this here is our throat. That's pretty sloppy writing. Sorry. And then we have our, well, what we should have would be our 65, but we're not going to get too carried away with this right now. We'll show you this later. Our 45, and then often what happens is they just get a top cut on there. So there's your 45, okay? And then the top cut, and they use the top cut to bring the top diameter of the 45 down, and they often leave a good bit of a ridge here, like this, okay? And then you get the, hope I left myself enough room here. There's your, and then your 45. So that's a little bit. Let me fix this up. Oh, should have screwed that up. Oh, it's apparently not a dry erase. Okay. Anyway, sorry. There's our throat. There's our 65, our 45, and there's that flat they cut, and then you end up with this nasty little ridge all the way around there. I'll do this like this, see what I can do here so I don't block the camera. Okay, so now here's where your intake valve is. Seating, right? Well, there's a bit of a margin on there. Right, like so. And there's our stem. You can see how much this valve has to open before it gets any airflow. Again, I got the wrong marker, don't I? So if you open this valve 30 thou, this is down here now. You're hardly getting any airflow. So you're wasting the first 30 thou of your valve lift, not just the 30 thou, but the duration that you have used to get you that far. And this air has a very narrow pathway to go. Not to mention the fact that you got quite a block during your overlap between your intake and the exhaust. Now, if we can erase this, our throat has a very specific diameter. In this particular case, we want our throat to be 89 to 91% of our valve diameter. So we've ported all of this, and like I showed you with the valve, we brought this out to our 89%. Now we're going to go in and we're going to cut our top, our 30, our 45, and our 65. So basically what I did was I used my 10-degree cut to eliminate the recession we had from the previous valve jobs. And then we go in and we cut our 45 degree until we have our valve seating where it's supposed to seat within the 45 degree of our valve. And then we trim back our 30 degree, and then we cut our 60 degree to achieve our 45 degree width. Our 45 degree width is, on the intake, 60 degrees. On our exhaust, we went to 80. No, not degrees, thousandths of an inch, sorry, and thousandths of an inch. The exhaust is slightly bigger. We want a larger contact area for the heat to transfer into the head so the coolant passages can take it away. Also, by going to a narrower seat, which isn't recommended for street use, you can obviously increase your airflow. going to a wider seat will increase the temperature, the heat transfer. But the problem is if you go too wide on your exhaust seat, you're not going to have enough pressure on the seat to keep it clean. It's going to be too broad. It's going to distribute the load. You're going to have a carbon buildup. That's going to pit the seat. It's going to pit the valve, and it's going to lead to burnt valves. Now, also, because now we've eliminated all that awkward stuff we showed before, now is our valve, which would be seated here like it is here. If we open that valve, I think we used 30 thou as an example in the last one. And there's your valve with your 45, and then it's got your 30-degree back cut on it. And there's your margarine. Look how much additional room now you're going to have for airflow. So basically, you've got the air flowing faster. You got more air going through your overlap, which is going to pull more air off on your intake. That's a pretty dramatic improvement. Plus also, now, here's our area between our intake and our exhaust, and then we start coming up with our valve angles and into our port. Look how free now the air is to go, the pulse from the exhaust to pull on the intake without that valve being shrouded by a poor valve job. So basically, that's it in a nutshell. I will show you now. I got to play with my valve or my camera angles and all that kind of stuff, figure out. But in one of our next series, we're going to show how to grind these different angles, and then that'll start to make a lot more sense. But basically, you can see how a bad valve job is going to kill your performance. It's going to kill your flow. You're going to lose the first 30 to 50 thou of your valve lift. At 50 thou, you've already lost probably 15, 20 degrees of duration. You're killing the camshaft that you spent big money for. You're killing the flow. The other thing, too, I'd like to mention is consistency. If you go back and you look at the video, maybe I'll see if I can post a picture where I wrote all the numbers down. You'll see I keep my angles and my widths of my different seats and my different cuts exactly the same. I also keep, so here's your 45, here's where your valve basically seats. I keep the depth of the valve within 5 thou. I'll get more into that when we talk about the top of the head, why I do it like that. So here we are, back at the heads, just to recap. There's our different valve angles. There's our different thicknesses of the seats. The exhaust is slightly wider on the 45. Your top cut, especially your top cut, the width of that's dependent on how much it takes to clean up the surface. Your 65, you just cut your 65 until the bottom of your 45 is where you want it to be. The important factor there isn't the bottom of your 65, but the width here and here, your throat diameter, which has to be on a decent street engine. You want this throat diameter here to be 89 to 91% of your valve diameter, like we spoke about earlier. Your exhaust, you want to close that up a little bit. You want that 86 to 90%. If you're buying a set of heads that have been ported by somebody else, that's probably one of the more crucial things. Make sure you still have your 90% throat diameter. Now I got to clean these heads. I'm going to totally assemble this one because it's the thinner head. I'm going to totally assemble it. I'm going to take it over. I'm going to CC this chamber. This one here, I'm going to assemble one valve, one intake and one exhaust in one chamber, and I'm going to CC that. This one here I didn't do the final cut on. I had to do the valve job first. I'll see what the CCs are. I'll do the math to see how much I have to cut this down. with my measurement I did for the thickness of the head, this one comes up at 20 thou thicker. So we left lots of room to finish that off. I want to confirm that by CCing the chambers, and then we'll cut that, do another cut on this, bring that into spec. Then we will have two exactly identical cylinder heads, identical in every way. The other thing we do on these, kind of jumping ahead here, but we're going to mention it now anyways, is our seat, our spring seat pockets. I keep them as close as we can, within 5 to 10 thou on all of them. So my spring installed height will be the same on all of them. So if you're at a drag and drive event, or if you're, an oval track racer, whatever you are, and you have to do an emergency repair, something goes wrong, you don't have to worry about this having a 60 thou shim, this a 15 thou, this a 30 thou. Every shim on both of these heads will be exactly the same to bring our spring installed height within spec. That way, if you have to do a repair, you can take it all apart, you can throw it back together. Both heads are identical, both valve jobs are identical, both spring installation heights are identical, both chamber CCs between the heads, all 8 of them will be identical. That's just how we do it. So, okay, everyone, have a great day. Thanks for tuning in. Oh, hey, I keep forgetting. If you like what we're talking about, if you like what we're doing, please subscribe. And, hey, happy burnouts.